Hello students, welcome back to the fourth video of this playlist. In this video, we will be solving question number 4 from the most recent past paper of Mechanics 2, which is the October 2024 M2 paper. So let's get started with question number 4 of the paper. So here it shows figure 2. It shows the uniform, the figure 2 shows the uniform lamina ABCD shown in figure 2 is in the shape of an isosceles traphizium. Okay, so BC, the side BC of the traphizium is parallel to AD and the angle BAD is equal to the angle ADC. Okay, so isosceles traphizium, so two angles on the opposite side will be equal. Okay, that is BAD equals to angle ADC. Okay, so BC equals to 5A. BC equals to 5A. The length of BC is 5A and the length of AD it is 7A. The perpendicular distance between BC and AD it is 3A. The distance of the center of mass of the traphizium ABCD from AD is D. Okay, so in part A, the question is asking to show that D equals to 17/12A. So 17/12A, that means we have to find out the center, the distance of the center of mass of this traphizium from the side AD. So for that, we will consider moments about the resultant moment about the side AD. Okay, so for part A, we will considering moments about AD, because we have to find out the distance of the center of mass from the side AD. So what are the moments? Look, we will divide this shape into three parts. So the first part, it is this triangle, this right angle triangle, and another part is the rectangle, and the last part is another right angle triangle. Okay, so if you consider the moments, so moments is basically moments is equals to Fx, right? So Fx, force, so here the force would be the area, force will be the proportional to the area because this is a uniform lamina. Okay, since it is uniform lamina, so we will consider the force, it is the definitely the force is the weight, so weight is dependent on the mass, so mass is proportional to the area of the lamina. Okay, so area of the first triangle, the area of this right angle triangle is basically, if you say this is 7A, this is 5A, so this distance to this point to that point, its distance is 5A, so this distance is just A, this distance is just A, and this is 3A. So the area of the triangle, it is half times base times height, right? So the mass would be half times base is A times height is thrice of A, so this is the mass, so we will multiply by G to get the force. Okay, and its perpendicular distance of the center of mass of this triangle, center of mass of this triangle, it is the average of the three sides, average of the y coordinate of the three sides. What did I mean? Look, for a triangle, we know that the center of mass is basically at a point that is situated at the average of the coordinates of the three vertex. Okay, average of the coordinates of the three vertex of the triangle. So in this case, we are considering only vertically, that means the y values. So along this way, it is the x value is 0, so y value x along this way, not the x value is 0, along this way the y value is 0, so this y value is 0, the y value of point A it is 0, the y value of this point is 0, but the y value of this point B it is thrice of A. So that means the y coordinate of the center of gravity of this triangle, it is 3A over 3, average three sides, three sides, that is 3a over 3. That is the center of gravity, the center of mass has y coordinate just a. Okay, so we will multiply the y coordinate of the center of gravity. This is the moment for the for the weight of the triangle only. Next, the moment for the weight of the rectangle. So area of the rectangle is 5a times size of a, which is 15a squared. So that would be 15a squared, and its center of mass, it is halfway, right? Halfway, this is here. So halfway, it is basically half of 3a, that is 3 over 2a. Okay, 3 over 2a. I didn't multiply g there, g is there. Okay, this is the moments due to the weight of the rectangle. And at last, the moment due to the triangle CD, the triangle that has the hypotenuse CD. Okay, so for this triangle, the area is the same as that of the first one. So the area would be half times base times height times g, that's the weight. Its perpendicular distance of the center of gravity, look, center of mass, the perpendicular distance of the center of mass would be the average of the y coordinate. So this y coordinate is 0, this y coordinate is 0, but this y coordinate is thrice of a. So the average of the three y coordinates, it is 3a over 3, which is just a. Okay, so this is the moments about AD. So this is equals to the resultant moment. So the resultant moment is the total, the resultant moment is acting through this center of gravity. Since it is symmetrical shape, so definitely center of gravity will be of the whole shape will be here. Okay, will be at the middle, right at the middle. Okay, so the total area is what? The area of the trapezium, area of rectangle is 15a squared. We can get it from here. The area of the rectangle is 15a squared, and the area of the triangles, it is half times base times height, that is 3 over 2a squared, right? So 3 over 2a squared, it's the area of one triangle. So 3 over 2a squared times 2, that much g. Okay, this is the mass times its perpendicular distance. We need to find out, this is d, because d is the distance of the center of gravity, center of mass, from the side AD. This is d. Okay, we don't know the value for d, we need to figure out that value of d. So that's why this is the resultant moment. So the resultant moment will be the moment due to the total weight of the whole lamina. Okay, now calculate. Okay, so you will get a that will make it a cube. So 3 over 2 a cube g plus 15 times 3 over 2. So that is 45 over 2 a cube g plus 3 over 2 a cube g equals to 15 plus 3. It is basically 18 a squared g d. Okay, 3 over 2 times 2, it is basically 3. So 3 plus 15, it is 18. That's why 18 a squared g d. Now cancel g from both sides. Okay, a squared, also a squared can be, a squared g can be cancelled from both sides, isn't it? So if you do so, 3 over 2 plus 3 over 2, it is 3. So 3 plus 45 over 2. 3 plus 45 over 2, that is basically 51 over 2. So 51 over 2, a squared g cancelled out from both sides, so a will remain here. So 51 over 2a equals to 18 d. Okay, so the value for d, make d the subject. So 51 over 2 over 18, that would give you 17 over 12a exactly. right? And that's basically what part A of question number 4 has asked to show. 17/12a. Fine. Okay, next is part B. In part B, the question says the uniform lamina PQRS is a rectangle with PQ equals to 5A, PQ equals to 5A, and QR equals to 9A. The lamina ABCD in figure 2 is used to cut a hole in PQRS to form the template shown shaded in figure 3. So this is the template you can see in figure 3. So PS, the side PS is parallel to AD. The perpendicular distance between PS and AD is A. PS and AD. The distance between PS and AD, it is just A. The perpendicular distance of A from PQ. From PQ, the distance of A, it is just A. Okay. The template is freely suspended from P, from point P. They have suspended the template at this point P. Okay. And hangs in equilibrium with PS at an angle of theta to the downward vertical. So part B is asking to find the value of this theta. Okay. So we have to find out the value for this theta as this template is suspended at point P. So before finding out that theta, we have to consider like where we have to consider the position of the center of mass of this template from the point P. So definitely it is symmetrical. We can see from the template that it is symmetrical. Since it is symmetrical, so we can easily understand that the center of gravity, center of mass will lie right at this middle, right? It is symmetrical shape. That's why. So we got the position. Like if you consider the position of the center of mass from the point P, basically horizontally it is at which point it is basically 9 over twice A. Okay, so using symmetry for part B, we can say using symmetry, uh, the position of center of mass from point P, horizontally it is basically x along the x-axis. Horizontally it is x equals to 9 over twice A. Okay, 9 over 2A. So we got the position of the the center of mass of the template from the point P horizontally. It is 9 over 2A. Okay, so now we have to find out the position vertically. So for considering the position of the center of mass vertically, we have to consider the resultant moment, right? Because we don't know exactly where the position of the center of mass vertically would be, right? So let's consider moments. Considering, why is it having a problem? Okay, look. So considering moments about P vertically. Okay, so if you consider the moments vertically, now the moments. At first, the moment, there are two moments. One moment is due to the whole rectangle PQRS. Okay, so this moment is due to the weight of the rectangle PQRS. So the mass of the PQRS weight, it is proportional to its area. So the total area of the rectangle PQRS, it is 5 times 9 A squared, which is 45. So 45 A squared G times its perpendicular distance from P. It is basically right at the middle for the rectangle, right at the middle. So it is 5 over 2A, halfway, vertically halfway of 5A, which is 5 over twice A. So we got the moment due to the weight of the rectangle PQRS. Okay, from there we have to subtract the moment of the isosceles traphizium. So the total weight of the isosceles traphizium, we got in part A, it was 18 a squared, right? Look at here, it was 18 a squared g. So it was 18 a squared g. So 18 a squared g times. Now be careful while you consider the perpendicular distance of the center of mass of the isosceles traphizium, because we are considering moments from P. So we have to add this distance A with the previous distance. Why? Because this side AD of the isosceles traphizium, it is A distance above of point P. Okay, so earlier in part A we got from AD, the center of mass of ABCD, it is at a distance of 17/2 to 12a vertically, right? But now with that distance D, we have to add A. Okay, so 17/12 a plus A, so that would give you 17/12 plus 1. So 17/12 A plus A. Okay, this is equals to 45 minus 12. Okay, 45 minus 18, that is basically 27. The resultant force, that is resultant weight, this is 27 a squared g, and we need to find out the y, right? X is known, we need to find out the perpendicular distance of the center of mass of the template from point P. Okay, so this is y. Okay, so now do the calculation. 45 times 5/2, this is basically 225/2 a cube g. Okay, minus 17/12 plus 1 times 18, this is basically 87/2 a cube g equals to 27 a squared g y. So on both sides we can cancel a squared g, so you will get 27 y equals to 225/2 minus 87/2, that would give you 69. Okay, 69a. A squared g cancelled from both sides, so y equals to 69/27a. So 69/27, it gives 23/9. 23/9a. Okay, so we got that the perpendicular distance of the center of mass of the template from the point P, it is 23/9a. So we got this distance, it is basically perpendicularly it is 23/9a, and horizontally it is 9/2a. Okay, now when the template will be suspended from the point P, okay, it will be in equilibrium when the when it is making, okay, when it will get suspended along this way. Okay, because as you suspend it from point P, the center of gravity will act this way, the center of mass is there, so there will be resultant moment in this way, right, due to the weight of the template, and therefore the template will rotate in this way. Okay, and it will keep rotating until this line, this dotted line I have drawn, this dotted line is vertical. Okay, so when this dotted line, the P2, let's say this is O, point O, the point OP, the line OP, when this OP is vertical, the side PS will be at an angle of this theta. Look, this is the theta, angle theta. Okay, this is the angle theta. So the vertical will be OP, and the angle theta will be between the vertical OP and the side PS. Okay, so we need to find out this angle theta. So this angle theta can be found using tan theta, right? Okay, so let's find out tan theta. Look, so tan theta would be opposite side over the adjacent. Opposite side is basically the y coordinate, right? 23/9. That is the distance of the center of mass of the template from the point P vertically. This is 23/9. This is the opposite side. So 23/9 over the horizontal distance. Horizontal distance is not 17 over. This is 9 over twice A. Okay, 9 over 2A. Okay, now from there, tan theta would be A cancels out, so 2/9, that would give you 23/9. Okay, so the angle theta would be tan inverse 23/9. So tan, okay, the angle should be in degrees definitely. So tan inverse 23/9, that would give you 68.6 degree. Okay, the angle we got for theta, it is 68. Okay, 23/9. Okay, 23/9 over 4.5. It gives, okay, wait. It gives 46/81. 46/81. Okay, let me check again. 23/9 divide 9/2. This is 46/81. So tan inverse answer, it is not 81. It is basically 29.6 degree. Okay, this is the value for the theta. This is the angle that the vertical OP will make with the side PS, as it is suspended from point P. And that's the answer for part B. Fine.